Today I'm going to show you how to build web APIs that scale using the AWS serverless stack. This site right here that we're looking at is on SkillMix, and I'll include a link to this architecture so that you can try it out for yourself. But today we're going to use this environment to do our build out. So what is this architecture? So this architecture is one that can take incoming requests from the internet, and this is the API gateway that accepts those incoming requests. It then matches them on a route, path, and then we'll forward them to Lambda. In our case, the Lambda function is just going to log some events to CloudWatch, but you could have that Lambda function do anything that you need it to. It's a very quick solution to stand up. It's a powerful one as well because you get near infinite scalability, and it's good to know how to configure this. So the way it works, let's just dive into this a little bit more. For those that aren't familiar, API Gateway is a managed API gateway service by Amazon, and it will handle the ability to create paths like /pets or /telephone, and then you configure what happens when a request goes in that path. So you might have it route to a Lambda function, or you might have it just insert data into DynamoDB, for example. There's a ton of possibilities here. The way we configure it in this architecture is we're using Terraform, and we need to create several resources that are listed here. The first one is the API Gateway resource itself. This is where we give it a name, we give it a protocol type, and we configure it to be the HTTP version of REST API. Next, we create a stage resource, and this is needed to match the API Gateway configuration requirements. A stage is essentially a life cycle state, so it could be test, dev, prod, etc. So we create that. Then we have an integration, and this integration will integrate our gateway to Lambda, and it specifies how that integration works. Then we create a route. A route is a path, like I said. It could be /pets, /dogs, etc. We create a log group, a CloudWatch log group for this, and then we also create a Lambda permission resource that gives permission for the gateway to interact with Lambda. If you're exploring this on your own, you can see all the resources below, but I won't go over those right now because we're going to build this pretty soon. Okay, so that's the gateway resource. The Lambda resource, for those that don't know, Lambda is a functions as code service, and this is one where you write function code, upload it to Amazon, and Amazon will take care of running that code either manually or by some sort of invocation via an app or another AWS service. So functions as a service. And this one we will also configure using Terraform, and we will create these four resources here. So the first one is the Lambda function resource, and this defines what our function is. Stuff like the programming language, a path to the actual function file, etc. Then we create a CloudWatch log group, and this will be responsible for logging information related to Lambda. We then create an IAM role, and this is attached to our function, and this gives our function the ability to interact with other things within the cloud. And then we create a policy that attaches to the role, giving it the actual permissions. Okay, so with that, the next thing we're going to do is start the lab environment. So this is a feature of SkillMix and this application right here. If you click Start Lab, if you do have an account, if you don't, go get one. It's pretty awesome. What happens right here is we'll go out and provision an account for you, configure it properly, and then give you access to both the console as well as programmatic access, which is what Terraform needs to do its thing. So I'm going to let this boot up fully, and then I'll come back when everything's ready. Okay, great. Now our lab is ready. So you can always come back to this tab if you need to grab the username for IAM or the password, or for Terraform you'll need the secret key and the access key. You can also log into the console with that link right there. Okay. So let's click on the lab hat, and we get the build steps. So we just completed the Start Lab step, and now it is configured the CLI step. You do need the AWS CLI to complete this lab. Actually, you need it to complete Terraform or use Terraform in general. So if you don't have that, you can go install it now. And I do have instructions on my website on how to do that. So the way that you work, or that it works, is you add the lab credentials to the credentials file. Here's the path on a Linux or Mac machine. Here's the path on Windows. You will need to add a profile name, so use smx-lab and then configure the keys from the lab environment there. So for these two keys, you would use the access key and the secret key here. Okay, so once you have that done, we can move on. The first thing we'll build is the Terraform and provider blocks. I'll just grab the code here and then we can step through it. So the Terraform block, we need to configure the required providers. We are using the AWS provider, so we set the version there and the path. We're using the random provider, which is provided by HashiCorp, and this allows us to generate temporary or random names. And we use the archive provider to create our zip file. We also specify that we're going to use Terraform 1.0 or greater here. Next, we have the provider block. We are using the AWS provider. We set the profile to the name of our credentials that we configured in the credentials file, and then we set the region to a variable. Let's do the variables now. I'll copy over the whole list and then we can walk through it. The first variable that we're going to configure is the region. So again, this argument right here points to the region variable, and we're using US West 2. We're also going to set the S3 bucket prefix, and it's going to start with this string of text. We create a variable for the Lambda name. We create a variable for the Lambda log and API gateway log retention, and we're setting both of those to 7 days. Great, so we have our variables set up. Next, we'll create the data blocks. These blocks will allow us to get information from the account that we have. So we're going to set the AWS caller identity data block, and this will provide information such as the account ID, the ARN of the user that is configured for this Terraform project, etc. So we use this in a couple places throughout the project. And then we're also getting the current region. Alright, let's move on to the S3 bucket. So the way our project works is that we have a local file on our computer that will be the Python function that Lambda executes for us. We will, when we do a build of this project, that file will get zipped up and sent to S3, and then it'll go from S3 to the Lambda service. So we do need to create a bucket here. Let's go ahead and copy over our bucket resources. So the bucket resource, we set the prefix of the bucket. So this is what the bucket prefix will be. We also specify force destroy to true. This allows Terraform to destroy the bucket even if there are files in it. If you set this to false, then Terraform will make sure that you have to delete all the files in a bucket before you can go ahead and delete it. And then we create an ACL. So we create this ACL, we set it to private, and we apply it to the bucket that we just created. Okay, so next we'll create the Lambda function resource. So this is a Terraform resource block that configures how our Lambda function will work. So let's go ahead and paste it over and then walk through. The first thing we do is set the function name, and this points to our variable. We give it a friendly description, as you can see here. We do point to the S3 bucket that we created, so that's something that we've already done for this resource. And then we set the key name, but we haven't created this key yet. We'll create that a little bit later on, but this essentially will be the actual file name as it sits on S3. We set the Lambda function runtime to Python 3.8. We give it a handler, so this is the path to the handler function. The app is the name of the Python file, so our Python file is going to be called app.py. And then handler is the name of the function in that file, and that is our handler path. We also set a source code hash argument, and what this does functionally is that if the hash changes, then on a Terraform apply, Terraform will know to re-upload the file and to redeploy a new file. So for example, we'll start off with one version of our Python file. If we make some sort of change to it and run this again, run a Terraform apply again, Terraform will know that the file contents changed and then redeploy the function. We set the role, so this is the role that we'll create a little bit later, and this is the path to it. We specify the R in here, and then we specify that this is going to get created after the CloudWatch log group is created. That's what the depends on flag does. So the next step here is creating the actual function file. I want to skip this step for now and come back to it after we finish the Terraform configuration. So just hold on and we'll get to that momentarily. So the next thing we do in the Terraform configuration is we create the Lambda archive file, an S3 object. Let's go ahead and copy this over and then I'll step through it. So the archive file is our zip file, and we have to specify that we're going to create a zip file, so that's what the type is. We give it a source directory, which we didn't create yet, but in our working folder we will create a directory called src, and our Python file will be in that folder. So that's the source, and then we set the output path to create a file in our root module called src.zip. So this will create our zip file for us. The next thing will actually upload that zip file to the S3 bucket we created. So here we're pointing to the bucket above that we previously created. We set the key, so this will be the file name as it exists on S3. We set the source, so this is the archive file that we just created here, so you can see that path, archive file.lambda.zip.output path, which is there. And then we give it an e tag, which is pointing to our file path as well. All right, moving right along here, we're cruising and making a lot of progress. So let's go ahead and create our Lambda role and attach a policy to it. So we'll copy and paste. So this is the role resource, and we call it Lambda exec. You see that there's two commented lines here. If you're running this code in a SkillMix lab, you do have to uncomment this line. If you're running it on your own account, you don't have to uncomment it. But essentially this is required to limit the role's ability to create new roles in the Amazon account. It's more of a security feature on my side. Okay, so that's the first step. We give it a simple name here, and then we do this assume role policy, and we're using the JSON encode function to encode this snippet here. So what this does is it allows the Lambda service to invoke our Lambda essentially. This is required for the service to be able to start new invocations of our function file. So you got to have that. And then we are going to create a policy attachment. So we're going to point to the role that we just created, and then we're going to point to a policy that currently exists on Amazon. So this is one of their built-in policies, and it is the basic Lambda execution role. So we attach that, and now our function has all the permissions it needs to run. Next up, we'll create the actual API gateway. So per our design, this is what sits in front of the whole solution, and we will create it now. So let's go ahead and paste it in, and then I'll step through. So we'll give it a friendly name. We specify the protocol type. There's two versions of the API gateway. There's HTTP and REST. You know, net, the HTTP version is less feature rich and also lower cost. So if you do need certain features like API keys being generated, you'll have to use the more expensive option. But right now we're just using a very basic version of this, so the HTTP version will be okay. And then we set our CORS configuration. This allows basically anybody on the internet to interact with this API. So the whole thing's open. Okay, and then just to kind of walk through this, so we're allowing all the methods, we're allowing all the origins, and we're not setting any specific headers right now, so it's kind of a blanket open up to everything configuration. Okay, so the way that the gateway works is that we have to create a stage. A stage is tied to a lifecycle state. That's how they refer to it on the Amazon side. A state could be something like dev, test, stage, production, etc. So we're just going to create a default stage, and if you were doing this on your own and you were doing something in production, you might have multiple stages for the gateway depending on your requirements. So what we do is we create this stage resource here. So let's go ahead and copy it over and then walk through it. So what this stage resource does is it points to the gateway that we just created. So this API ID, this is applying the gateway up here. All right. We set the name, so we're using a default placeholder for the current stage, and this will do a wildcard. This is a wildcard setting, so it applies to essentially any route. We set auto deploy to true. And then we set our access log settings. So the first thing we do here is we point to the CloudWatch log group that we'll create. And then we give it a very specific format so that when events are logged, the event will be logged in this structure. So we have request ID, source IP, request time, the protocol used, the method used, the resource path, the route key, the status, etc. And it's going to look very nice in our CloudWatch logs. And then we do say that we will require the CloudWatch log group resource to be created before we create this resource. That's what the depends on flag means. So we just created the stage, and then we're going to create the integration to the actual Lambda function. So the first thing we do when we create an integration is we specify the API ID. That's pointing to our API gateway. And then we specify the integration URI, and this is pointing to our Lambda function resource that we created previously. And then we set the integration type to AWS proxy. Okay, we're almost done here. So the next step is we create the route, and a route is, like we show here, it's a path that gets appended to the URL. So example.com/page, page is the route, etc. So we can get really creative here, and you can create any route that you want. What we're going to do, like here's the actual route key. We're going to actually just apply the default wildcard. So this will actually mean that we respond to any route that's appended to the end of the URL. You can do another format, like and you can have multiple, so you can say get page, and so this would apply the get method to the page route. But we're not doing that for now. We're just going to use default. And then we have our target, which is our API gateway. And this is actually pointing to the integration resource, not directly to the API gateway itself. Okay, so one of the last things we'll do before we get to the CloudWatch resources, we will create a Lambda permission resource. This allows the gateway to invoke the Lambda function. So it's setting up that permission configuration. So we have a statement ID, and we allow execution from API gateway. We set the action. This might look familiar. It's an IAM policy formatted action. We point to our function name. We set the principal. So the principal is the API gateway service itself, and this is the URL for that, or the domain name for that. And then we set our source, and the source is pointing to the actual gateway itself. So this is the gateway resource that we previously created. And we do have some wildcards here at the end to apply to anything that might be added to that resource ARN. Okay, so now we can create our 2 CloudWatch log groups. And these log groups, one is for Lambda and one is for Gateway. We give it a friendly name, and then we give it a retention in days, and we set the retention previously in our variable configuration. Okay, so we just finished writing all the code we need to deploy the resource. I'm going to show you now how to create that Python file that we previously skipped over. Let's create that Python function now. So on the build step list, move to the step of creating the Lambda function file. And I've switched from the code editor over to a terminal so that I can complete this last step. The first thing we'll do, if you look here, if you read this, it says create a folder called src. So we'll do that and we'll move into it. Then we create a file called app.py. So I'm using VI to edit this, and let's go ahead and paste the contents of this file into it, and then we can walk through it. So the very first thing we do is we make some imports, so you can see those there, and then we set up the Python logger. Here's our actual handler function. So we log information first, so this will actually, when the Python Lambda function is run on the service, all that information will be logged to CloudWatch. Then we create an event object, which is a friendly structure or has information from the request itself. So you can see here the function name. We're using the context.function name value to feed that and to build that value. And there's some other stuff there that you can read through. Then the next thing we do is we formulate our response. So we're saying if the event request context is basically if it's a post to this, then we'll respond with this body right here. And the main difference between this and the other part is that if it's a post request, we're going to return the actual contents of the post body along with our response. Great, so that's all we need for that. Oops. Hit escape, right quit. Okay, and let's move back into our main folder. Now let's complete the deployment of Terraform. Okay, great. Now let's go ahead and deploy this solution. So back at your terminal, make sure you're in the right directory, and let's run Terraform init. So we've already got some of the plugins already downloaded, but if you don't, then the download will happen here. Next we run Terraform apply, and this will go out and commit our changes. Yes, and then we'll wait for this to finish. Okay, great. So we have all the infrastructure has been created. Let's go ahead and grab the URL of the gateway, and then just type in curl and then paste the URL, and we should get a response. So here's our response. It was successful, and this response body, this was created per the so if we look at the Lambda file and we did a get, so this would be it. So we have the status code, headers, and the body. And if we look, in addition to the event object. So there we go. Everything's all set.